Okay, students, so here we have a cup of water. How could we change the state of the water?
Well, we could put it in the freezer.
Okay, what other ways can you think of?
Well, we could put it on the stove and boil it, and I think it'd turn to steam.
Interesting. So if we were to put this water in the freezer, what would happen to it?
It would turn into ice.
All right, so if the water turns into ice, what is the difference, if any, between the mass of the water and the mass of the ice?
Well, I think if you put it in the freezer and it becomes ice, it has to be heavier because ice is heavy, and so water is light, so the ice is heavier.
Okay, what do you think?
Well, I think it's lighter because ice is kind of like snow, and if I have a handful of snow, that's pretty light, and I think water is denser and heavier, so I think the ice is going to be lighter.
Interesting. Any other thoughts?
Well, I don't think so, because whenever I have my water bottle and I freeze it, it expands, so it takes up more space, and so it has to be heavier, and plus, everyone knows that solids are heavier than liquids.
Those are some interesting points. So now we are going to conduct an experiment about this cup of water. In front of me is a balance scale using a ruler. You can see that the mass of the sand is weighing down one side of the scale. However, if we put the water on the opposite side of the scale, the ruler will be balanced. This shows that the cup of sand and the cup of water weigh the same. We're going to use weight to test the mass of the water and the ice using this balance scale. According to Hadley, the ice is going to have more mass than the water. So Hadley, will you show me what the scale will look like when we put the ice on it, according to your prediction?
If the ice is heavier, then the sand will be kind of up in the air like that.
That's right, because why?
Because the ice is heavier than the sand, and the sand weighs the same as the water, so the ice will be heavier than the sand.
Good explanation. Now, according to your prediction, Cara, the ice is going to have less mass than the water. What will the scale look like when we put the ice on, according to your prediction?
Well, because this will be the ice, and I believe that it will be lighter, I think the scale is going to look like this, because the sand is heavier.
Okay. So now we're going to put this cup of water in the freezer. We're going to let it freeze overnight, and then tomorrow we're going to test our predictions.
Sounds good.
Okay. So as you can see, our water froze into ice overnight, so now we have our cup of ice, and we're going to see if our predictions were correct. Interesting. According to the scale, the water has the same amount of mass when it's frozen into ice. Why do you think that is?
Well, in science class we talked about the particles, and I guess there weren't any really particles created or taken away, so I guess it kind of makes sense.
Is that why they have the same mass? Because there are no more or no fewer particles?
What do you think?
I think it's because there's the same amount of particles.
Intriguing. Let's predict what will happen if we melt the ice. What do you think will happen?
Well, I know that whenever I freeze my water bottle for practice, and it kind of blows up, but for some reason it still always freezes back to the same amount of water. So if that's correct, then I think the ice will freeze to this, or the frozen ice will melt to the same amount of water.
So it will have the same amount of what?
Mass.
Okay. What else?
Well, I think because the mass stayed the same when it went from water to ice, that it would kind of make sense for there to be the same mass when it melts back into water.
Let's see if your predictions are correct. We're going to go ahead and melt the ice, let it melt, and we'll come back later and see what happens.
Okay.
So now that the ice is clearly melted back into water, we're going to test our predictions and our understanding of mass by reweighing the water against this cup of sand. And they weigh the same.
Wow.
All right. So your predictions are correct, and therefore we know the mass of any amount of matter is conserved or remains the same when it changes form, such as water into ice.
Wow, that's cool.